Okay, so welcome to our talk today. It's titled, So You Want to Be a Data Engineer. So why are you here? Is anybody already a data engineer? 3 guys,
Don't
or
be so
4
timid.
guys? No, no, we're going to get tested on this. So is anybody kind of thinking about moving into data engineering at all? Anybody not know what a data engineer is? Well, that's cool. We can work with that. So first, we're going to look at what is a data engineer. So the reason why we're going to look at this is we work in the data field, and we find that we're not particularly well known in our own area. So we have data scientists who we work with, who basically see us part of the data science process in terms of getting data to them for them to process into nice reports and analytics and things like that. We also have software engineers who think, again, that we're one of those, but with a focus largely on doing things with data as well as making things work with code. We have BI developers who just see us as the glorified ETL developer. And we have DBAs and data engineers who probably are wondering why we're here, because they're delivering data platforms, possibly a data warehouse, and they probably think that we're just stepping in their territory a little bit. So one of the other reasons why you should be here today is we have a skill shortage in data engineering. It's growing really, really quickly. Year on year, it's growing by about 50%. Just like to introduce you to everybody else that's with me today. We all work for a data science and data engineering consultancy called Advanced Analytics. And we've all come from different roles within the data field. So I'll just, hang on, why hasn't that worked? Sorry about that. So first of all, we have Anna, who is our software engineer. Anna basically just loves coding. She's our code cop and just improves us completely as developers. We also have East, who is our BI developer and general data guru. He really just loves Excel, and I think he's going to do the best just to prove that he's not just an Excel fanboy. Nice. And finally, representing the cool kids is me. I used to be a DBA, and believe it or not, probably can't believe it, this is actually my first time presenting, so just want to give out a shout to the community. I've been involved with community events for 10 years, and I can't understand why it's taken me so long to kind of give back in this way. You're all awesome, and one of the reasons why I now do this job. Lastly, data engineering is fun. We're very lucky that we come to work every day and do something that we truly love. We get to work with new technology, we get to work on innovative projects, and it's just a really, really cool way to spend your day. Although sometimes it's like wrestling a crocodile and a bear at the same time. So you do have good days and bad days, but it's mainly all good. So how are we going to help you become data engineers? We're going to split the talk up into 3 areas. We're going to go through a little bit about what is data engineering. We're going to look at the tools and the technology that we use. And then we're just going to give you a little bit of an insight into how we developed our careers to become data engineers ourselves. So the burning question, what is a data engineer? So earlier, we introduced a number of people within the data field who probably don't know who we are. They all have a number of data skills in specific niche areas. So they're all thinking, why do we need these guys at all? So we like to think data engineering takes little bits of subsets of the skills, adds a few other things, knowledge in cloud technologies, knowledge of big data systems, combines all of them to kind of make a hybrid of all the technologies. But this isn't an aim to replace all of those people within the data space. We kind of want to evolve data engineering teams that will work with data scientists in other areas of the data platform to deliver bigger data solutions, working in collaboration with these guys to deliver more value to our customers. So what does a data engineer do? So the traditional view of the kind of work that we do is we develop ETL pipelines. These are still very important to us. The majority of the things that we do involve getting data from source systems into a reportable state. But there's a lot more to it than that. And we need to have some expertise in modern data platforms, big data platforms. We need to know about modern system architecture, and we need to be able to develop things, which is where the engineering comes from. So we need to be able to develop specific bits of code to be able to understand problems. We also need some very, very solid soft skills. So we need to be able to talk to stakeholders and get a clear picture of what we need to deliver. And we still need to work with a lot of technology teams. So we still work very closely with data science, software engineers, and we work with business analysts to provide them with all the data that they need. So hopefully that little introduction to data engineering is give you some idea what we're all about. So we're going to start looking at the tools, and then we'll go on to how we got here. So we'll start with where this journey all began, and I'm going to hand you over to East to talk about where it all started. Thanks, East.
Thanks, Mikey. So, in the good old world, we had a data platform, a data warehouse, taking from relational source systems and pushing it into relational data warehousing. And we did this using a very similar, familiar process of staging, cleaning, warehousing. And we orchestrated a lot of this with SSIS. This is how we did things. And on the whole, this is how some people still do things. So we'd have like an overall orchestration package, and we would stage data. We'd then clean it, we'd create some dimensions, and we'd create some facts. And these are all like entity per entity transformations and processes and packages, with some dependency pipelines put in for good measure and stability. But as ETL developers, we have a checklist. We have needs and desires and wants. Ooh. So we want as low development code effort as possible in creating our processes. And we want to apply the same processes to as many things as possible in a consistent manner as possible too. And we want to do that across as many file formats and systems as possible, not just relational or having to rely upon some super flaky fat file reader. And we want to scale it up and down without the constraints of on-prem infrastructure. And we want to do it in an agile way and to build upon it in an iterative development process. And we want it to be supportable, so they can be picked up by almost anyone, right, instead of that person who has the in-depth, intimate knowledge of how that individual package works. So SSIS and other on-prem ETL tools can actually tick some of these boxes, but on the whole, it doesn't meet our needs. So we have the new world, and I'm going to hand over to Anna.
Thank you. Right, so we want to move into the cloud. You've heard about the cloud. It's awesome. Everyone's raving about it. But here we've got a montage of different tools that you could use when working in the cloud. So some examples there being Databricks, Synapse, Amazon Athena, Kubernetes, Amazon Redshift, Docker. The list goes on and on. So which ones should you be using? Which technologies should you be learning? Now, more realistically, we have several key options. So most of us here are working primarily with Azure. So within the context of the Azure architecture, we are primarily working with Azure Data Factory, Databricks, and Azure Synapse. So as data engineers at Advancing Analytics, these are the three core technologies that we mostly use. So here we have a diagram of a modern architecture. So essentially, this is us working in the cloud. So we've got our data sources, which can be essentially coming from a variety of different places. So it could be SQL Server, it could be a blob store, it could be files, so different types of files, so it could be Excel, Parquet, CSV, JSON. And then we're using Data Factory to essentially grab that data and push it into a data lake. So that's a data lake Gen 2. And when we push it into the data lake, we then want to actually work with that data, refine it, and get it into a state that we can actually essentially do decent stuff with it. So that's when we start using Databricks. So we're using Databricks there, essentially, to refine our data, to get it into a decent state. So we've got the raw and base layers there, but essentially, in the real world, we'd have, say, curated and rich layers as well. And that's that bronze, silver, gold that you may have already heard of. And then we're getting our data into Azure Synapse, and then we're able to actually visualize that using Power BI. And essentially, over the top of all of this, we are still using Data Factory. So we're using Data Factory to orchestrate, to actually trigger those Databricks notebooks. Orchestration and integration. So we're going to focus a little bit more now on ADF. So we've got an ADF primer here. We've got SQL. We're pulling the data from SQL, putting it into a table, and then we're able to essentially work with that. And we're doing all of that using Azure Data Factory. So we're performing there a copy activity, using essentially its own scalable compute there. And then we're able to use Databricks again to actually do the transformations and refine the data. So ADF in Azure. So we've got another architectural diagram here, where again we've got our source data, and we're copying that data into SQL, into our data lake. And then on the transformation activities, we've talked a lot about Databricks, but obviously in the Azure architecture, there are different options that you can be working with. So here we've got some examples. So we could be using just C#. We could be just writing some C# functions, and that is a viable option. And as a data engineer, it is your job essentially to decide within your team, within the company that you're working in, which is the best option. And essentially that may depend on the skill set within your team, what best suits that particular company, that particular project. And then when we've chosen that, we're actually able to transform our data. We then decide where we're actually going to put that data, so that's the destination. And essentially, again, you then have to decide what is the best destination. So we've got SQL there at the bottom. It could be Synapse. It could be Cosmos. It could be in a data lake. It could be in Blob. And as a data engineer, we have to assess and decide what is the best place for us to essentially put our data. So now we're looking actually within ADF. We're actually looking at an existing pipeline that we've got set up. And essentially what we are doing, and I'm just going to look at the screen here because I can't quite see. So what essentially we are doing is we have a pipeline that's going to run a Databricks notebook. So essentially we're starting our task. We're going to run the Databricks notebook. So that's that second task there. And then we've got happy and sad paths. So it's all great if when we're processing our data, we've got our ETL pipeline, and everything's going down the happy path, everything's working. But what happens when everything goes wrong? And this example here is showing essentially that split. So we've got the happy path at the top, and at the bottom there, it's showing where we can actually have that sad path, and we can handle that accordingly and do what we need to do with that. So whether that's logging, whether that's alerting. And ADF is essentially allowing us to do that. And then on the happy path there, when we're happy, we're going down the right path, we're able to actually work with that data correctly and get to the end of our journey. And here in ADF, essentially what we're looking at is just a list of some jobs that have actually run, some pipelines. And it's just an illustration to show you how ADF gives you that GUI and gives you that interface so you can actually visually see what is going on and see that your pipelines have run successfully. And then on top of that, we can actually visualize that more. We've actually got these diagrams here, these graphs that you can work with to actually look at the kind of the statistics on how many pipelines have actually run successfully, how many failures have we got. And as a data engineer, it's our jobs to monitor this and understand it and make sure that, again, we're on a happy path. So for those of you who may already be working with SSIS, you may have been burned. Essentially, if you are an SSIS developer or you know there's a lot of SSIS within the company that you work with, ADF does allow you to lift and shift. So you can run your SSIS packages within ADF. So I know a lot of companies are still heavily invested in SSIS. That is fine. ADF essentially does allow for that. And you can initially lift and shift, and then over time, you can rework them and actually get them working using different processes, different compute, to actually run those same ETL pipelines. So essentially, again, with ADF, use the flexibility of Data Factory. So there's loads and loads of features in there, so we're not going to list them all. We've just got 2 top-level ones there, essentially the lookup activity and the for each activity, so the for each allowing you to run multiple processes off of one. And the very basic select from systable activity, just illustrating there the lookup where you can go and get your data. But like I said, the list goes on the things you can do in ADF. So Data Factory recap. Orchestrates all data workflows in Azure. Best method of onboarding data to Azure. Use parameters for each and child execution. So just a brief summary there, essentially, of the highlights there of ADF. So this is a checklist there, low dev effort, many use cases, flexible formats, elastic scaling, agile, supportable. So a big pass there, big stamp on there. Data processing. So we're moving into Spark now, and I'm guessing that most of you know this, but essentially Databricks is Spark under the hood. So we've talked about ADF, now we're talking about Spark, one of the other big tools that we work with. Essentially what we're looking at here is an example there where we're getting some CSV data, and then within the context of Spark, we're able to work with Python, so Python being one of the key languages that we work with. And then we can create a data frame, add calculate columns, remove bad rows, and write to a table. So there's some of the key things that we'd be doing when we're actually working with, say, Databricks notebooks and working with our data. And then we're able to essentially write it to the table. So just quickly on data frames. Essentially, in Spark, in Databricks, data frames are really key. It's a really powerful piece of Spark when you're working with your data. And essentially, you can work with your schema, format, and location, working with data frames. And under the hood, you have all of your data distributed accordingly. So there we have just an example there of some Python, just where we're actually working with that. So we're doing a spark.read, and we're able to inject there the schema, the format, and the load. And finally, just expanding that a little bit. Is that right? OK, yeah. So essentially, what we've got here is just expanding on the different file formats and stuff you may be working with. Again, passing that through into Spark, and then outputting to many tables. So I'm going to hand over to Mikey now. Start talking about Spark options in Azure.
OK, so we're just going to take a quick look at the Spark options in Azure. Basically, the Spark option in Azure, as Anna pointed out, is Databricks. For those who don't know, Databricks is a data and AI services that's optimized for Azure. So it's highly integrated with the other services in Azure, such as your data lake, Azure Data Factory, machine learning, Synapse, and all the other Azure services, allowing you to store the data in a single platform and utilize the things like unified analytics and AI workloads. Good. I need to point it. Hang on. Cool. So Databricks is a third-party company. It's not part of Microsoft. They were founded by the team that developed Apache Spark at UC Berkeley. It's an open source project that started in around 2009 and went open source in 2010. It was then donated to the Apache Foundation in 2023 and became known as Apache Spark. Apache Spark is basically a framework for executing code in parallel across many different computers. So Databricks is a hosted implementation of Spark, which is just the reason why they've hosted it is just basically to simplify the management of clusters and interface, just to get some production-ready stability on it. This can be like really, really complex if you're doing that kind of in-house. The advantages of this over other Spark services is that Databricks will almost certainly have the latest release of the Spark engine, and it will also mean the quickest cadence of the versions that it's using. After this, I think we're going to, sorry, missed a bit. So Azure Databricks, the way that you work with this is largely through these 4 components. So we have the Databricks workspace, which is just a way of organizing the work that you're doing on Databricks. Think of it like a folder structure in Windows or something like that, and you're not too far away. What you can do with it is share things like notebooks and libraries with other users. You can kind of share them out, put security on them and that kind of thing. You can't actually run any of the code in the workspace without connecting to a cluster. So clusters are basically the compute layer of the Databricks platform. So basically they're groups of worker nodes that you basically just see them as a single unit, and they will allow you to execute code via notebooks, libraries, and you can also run SQL queries and things like that against them to process data. Next, we have notebooks. So anybody that's working with SQL notebooks, this should be really familiar to them, or if you're working with Joomla notebooks. So basically, it's just a way of putting your code into like a cell-based format. In Databricks, you can write these in Python, Scala, R, and I think you can do Markdown in that as well. To execute the code, again, you need to attach these to a cluster. We also have libraries. These are basically packages or modules that provide additional functionality. These can be custom written code in Scala, I believe, or Java. I think you can also use Python eggs or custom written packages. Again, you have to upload these via a package management utility such as Py or Maven to be able to use them. And now we're going to take a look at the Synapse offering in Azure, which Issa is going to walk you through now.
Cool, thanks, Mikey. So Synapse is your one-stop shop for engineering, especially if you are perhaps on the citizen data engineer side of things. So we've got like data pipelines, which, if you're familiar with ADF, is pretty much exactly the same thing. We've also got mapping data flows. So if you are coming from a SSIS background or an alternative drag and drop ETL tool, then that's going to provide a fairly similar experience. We've also got dedicated SQL pools, which is MPP, platform, serverless SQL pools, and provisioned Spark pools as well. So for everything that you might need for development, Synapse does contain it, which means it's quite a nice contender or even a complement, again, to Databricks. So Spark pools, so it uses a version of Spark in the same way that Databricks uses a version of Spark. And you use it on a per session basis. And like Databricks, you can use Scala, Python, or SQL. But interestingly, because it's now a Microsoft implementation of Spark, we can also use C#. So if you've got C# developers, we can start moving them over and doing some clever things with it. Also, we can do machine learning, and like with any other Spark type, we can start looking at some more unusual data types, which you'd perhaps be limited with a more traditional implementation of an ETL. So serverless SQL pools is perhaps my favorite aspect of Synapse. So it's build per query, it's properly T-SQL, and it allows for logical data warehouses. So it's more used to, I guess, a more cloud-native data warehousing, where you don't necessarily need the same structure and formality as you might with a more traditional enterprise data warehouse. And that is what you would get in dedicated pools. So if you need something which is properly managed, properly scalable, and very much your traditional enterprise data warehouse, dedicated SQL pools is going to be your friend. But again, caveats with this is that to make the best use of this, you need to have huge data volumes. Otherwise, you're going to be spending a lot of money and not getting much performance gains for it either. So just to recap, Synapse is your one-stop shop, and most of this is done through the Synapse workspace, but with options like serverless and dedicated, we can also interact through tools like Azure Data Studio, SSMS, and other like SQL providers. And Spark Pools tries to replicate a similar functionality and experience that you might have in Databricks, but on a lower version of Spark.
Okay, so hopefully through that one-stop tour of the tools that we use, we've shown you how we've come from kind of like an old worldy data warehousing application to a more modern architecture like this one, where we're taking data from multiple data sources on premises and stuff like that. We're using cloud-based technologies such as ADF, Databricks, Delta Lake, Synapse to basically have a more modern way of flowing data through to end users and making this data readily available. So we've looked at the tools and the technology, and hopefully we've given you a little bit of an understanding through both of those areas of what data engineering actually is. So next, we just want to kind of walk you through our own journeys from where we were before to how we got here. So we're going to start with a DBA. Is there any DBAs in the room? Woo, the cool kids. So being a DBA for me was a great job. It occupied a huge portion of my life. Sorry, I'm going to get quite emotional because my daughter's up there and things like that. So basically, it helped me grow both as a person and technically in ways I can't imagine. I became a dad, a husband, bought a dog. So all the aspects of my life are associated with my life as a DBA so far. So it was pretty much a bit of a wrench to move from it. My journey as a DBA started in my role there. So we're going to do this a bit like data engineering because that's where I'm at now. So my role there involved me being in application support. So I was working on applications that were basically written in VB that used an Oracle backend. And I used to get called up really, really frequently because there was problems with the Oracle database, largely because it was a load of junk. Essentially, the guys were running things with sysdba assigned to the Scott user, which still had the default password of Tiger, and it was a complete mess. So they just give me the option of either get called out more option or try and sort it. So I spent probably about 6 months to a year redesigning the whole the Oracle solution, learning how to script things so we could actually back the thing up, how we controlled user access and things like that, give developers their own logins rather than using Scott all the time. And as reward for that, I actually managed to gain a position in the DBA team. But as a junior DBA, they wouldn't let me touch Oracle, so they decided to pass me over to working on SQL Server, which is like, yay! But at this time, I was working with SQL 6.5 and SQL Server 7, which aren't particularly good products. I learned a lot about cursors because they were actually in the documentation on how to use the things. And I learned a lot of bad things in my time as a junior DBA, but it was kind of a good learning experience. I got to work with developers a lot. I got to write lots of Transact SQL code. I got to work really, really closely with developers to understand how they worked, as well as doing things like backups and stuff like that, all the things that you would associate with the DBA, but maybe it's not with all the skills that was necessary to do it completely in production. It was more still like a development environment and things like that. After working in that role for a few years, I got the opportunity to go into consulting largely through being made redundant. So as a consultant, I thought, right, I'm going to have to skill up pretty fast here. So I invested a lot of time, money into getting certification, walked into a few places and could talk the talk. So I was building good, solid, reliable SQL systems, doing a bit of performance tuning. My maintenance plans were exceptional, but it didn't feel cutting edge. I didn't feel like I was learning anything from it. So I had certs. I was doing things a particular way, but at this point, it still wasn't interesting to me. So then I discovered the community, I started asking questions. I wanted to know more, and found out there was a whole bunch of people out there that were like me, wanted to learn more, wanted to share more. So I invested a lot of time in the SQL community, coming to events like this, started a user group, started working on data relay, and really kind of skilled up big time with this. I got passionate about things like performance tuning and automation, so I learned some PowerShell through all of that. And that kind of gave me the confidence to do more, like work on bigger projects, go into systems architecture, start like looking at the possibility of SQL in the cloud for the clients that I was working with, and really, really do the kind of things that would put me in a good stead for being a senior DBA. So then, after all of that, I still wanted to learn more things, and I thought that I was kind of maxing out on kind of SQL, so I kind of went into a BI and data warehousing role. But I kind of agree with the dog when I say this, that I chose to do it in a SAP and Oracle hybrid. I'm going to lose you here. SAP and Oracle hybrid environment, but it was kind of good for me on my journey. I learned a lot about data modeling, ETL process. I worked a lot with Informatica, learned some things on automation, but that was largely with a product called UC4. Learned about big data. So what we were doing in this role was bringing information in through traditional data sources, doing the ETL transformations, loading that into Oracle, then using the Oracle to load it into SAP HANA, which is an in-memory system. So I got a good feel for the kind of things of actually dealing with big data. So as you can see, across my journey, I've picked up little bits of skills in kind of every step, from Unix shell scripting to be able to develop code, doing tons with SQL, learning about different data platforms in the cloud, doing lots on automation, getting some stakeholder skills. And then all I had to really do was kind of factor in some of the other skills that I needed for data engineering, such as Python, and then the soft skills such as like working in an agile environment and working with strategy and architecture a bit more. So as DBAs, you're kind of well fitted out in the data space to be able to transition to data engineering. You're working a lot with relational data technologies, which is great. You've also probably got a lot of experience working with cloud services, not just the data platform related ones. You'll be working with possibly Data Factory right now. You'll be looking at data lakes, different versions of SQL within the cloud. And you've probably done quite a bit of programming too. You'll all be great with SQL right now. You may have done some PowerShell and Python, all highly transferable skills that you're going to have already. So as well as the changes in technology, there's a bit of a change in mindset as well. These are the kind of things that I used to regularly think about as a DBA. It was kind of like, it was relational. I was thinking about how the data was coming in, make sure it was all correct for the environment that we were coming in, make sure it was all shaped correctly, make sure it was all accurate and things like that. High on my priority was keeping it secure, making sure it was backed up and things like that. As a data engineer, you've got to think slightly differently. You've got to kind of think that all the data that's coming in might not be the size and the shape that you want it. You've just got to like kind of program your head to think how you deal with it and think on your feet a little bit to come up with solutions for dealing with data that may be structured, it may be unstructured, and just work out ways of how to deal with that. You've also got to basically think parallel. Everything that you're dealing with in data engineering could be big data. So you've got to think, is the data coming on in the platform that we're going to be using, is it going to scale? So that's the main thing that we do. We make data and make the platform that it's coming in scale so we can produce usable data at the end of it. So there's a couple of soft skills that you've got going for you right now as well. You can talk technical. As a DBI, I like nothing more than learning everybody else's technology. So for example, if an AD guy didn't want to set up particular groups for me or policies for me, I could go and explain to why he can do that and the ways that he could do it. So I liked being as smart as all the other technical guys that I was working with. You can engage with the business. So being a good DBA, you've probably organize outage windows and being able to talk to the various groups such as finance and things like that to tell them why these kind of things are important. And part of that process, you've been able to explain why in plain English rather than in technical jargon. So I hope that sets the DBAs up in the room for thinking this is something that's really accessible to you. You already have a lot of great skills that you can use in this role. So I'm going to pass you over to Anna, who's going to talk to you a bit more about software engineering.
Thank you. So, do we have any software engineers in the room? Developers? Was there one hand? 0? Oh, cool. Brilliant. Thank you. We've got one person. Yeah, so a software engineer's journey. How did I get into data engineering? I actually started off wanting to be a photographer. I left school really passionate about photography. And that is one of my photographs, because essentially when you start learning photography, when you start studying it, they say, don't take photographs of living things. They run away. Just static, flowers, fruit, vegetables. So essentially I started studying towards my degree, which was visual communications. And at the same time, I got a job as a lab technician. So essentially, I hung around in dark, smelly places for a couple of summers, and I worked part-time there as well as I was studying. So it was as I was kind of in the dark room, on my hands and knees, my hands in the back of a printing machine in the pitch black, I thought, yeah, I like photography, but there's got to be more to life than this. And because I was already on quite a creative path, I then essentially evolved into being a graphic artist. That was, again, a summer job as I was studying, getting my degree. And that doesn't mean that I'm good at being creative and making things pretty. I design yellow page adverts, so if you want something to look like a yellow page advert, then I can do that. But I cannot make things pretty. But that was officially my title. And essentially, I use the Adobe software suite to do that. But as I was studying and as I was doing that, I really started to get into coding. I absolutely love coding. So initially, it was kind of HTML and JavaScript. And off the back of that, I essentially switched degrees from visual communications to do a computing degree. And off the back of that, I then started working as an application developer. And that's where I started hands-on working with XML, JavaScript, HTML, C#, and SQL, relational databases. Now, I'd done that on my degree, learned about relational databases and normalization. And I really loved it, but then I also love coding. So I went down the application developer route, but then also got to work with databases. And then I was a fully fledged software developer, software engineer. I've had many titles. It's the same skill set. And essentially, I started learning more skills and doing warehousing, so not just working with SQL and transactional databases. I was doing a lot of warehousing then as well. And again, I really love data, and so I really love the warehousing side of things. And I started using other skills such as, well, learning other skills such as JSON, Scala, YAML, NoSQL databases. So I've been doing this for quite a while, so as NoSQL databases come over the horizon, I started getting excited about those and working with those. And then most recently, I've been working with technologies such as Kafka, so streaming, working with big data, essentially, with tools like Kafka to actually get things from A to B. And I naturally evolved then into being a fully fledged data engineer. So I took all of those skills into being a data engineer. The skill set was exactly the same. But I just, essentially, my job title changed, and I spent more time just focusing on warehousing and all the loveliness that comes with data engineering. And off the back of that, I essentially became a data engineering consultant, because engineering your data can be hard, right? And when you're working with big companies, trying to actually get that data in the right state and everyone understanding it and everyone on board. Essentially, becoming a data engineering consultant was a kind of natural progression for me to kind of share my passion for both coding and data and bridging those gaps. So again, the same technology, exactly the same as when I was working as a data engineer. But on top of this, I was now working with and learning technologies, and this is with the data engineer and becoming a data engineering consultant. I was working with technologies such as Spark, so BigQuery, that's GCP, Synapse, and then doing Kimball schemas, working with Kappa and Delta design patterns and Lambda design patterns, and essentially working Agile and Scrum, which I was bringing over from my software development era. And then also learning things like Python, and also utilizing my DevOps and MLOps. I'm learning more MLOps as well. So bringing that in from software engineering as well. So software engineer to data engineer already had a lot of the core skills required. So if you are a programmer, or if you're a software engineer, back-end developer, essentially you already have a lot of core skills that are really sought after. You're used to working with continuous integration and continuous deployment and infrastructure as code. This is actually really key as well. So productionizing things like working with data scientists and productionizing models and things like that. Those sorts of skills really come into play that you can bring with you as a software engineer. And essentially, I brought software standards and processes into data engineering, and that's why I get called the code cops, because essentially, when we're working with tools such as languages like Python, which is very procedural and lets you do anything, I'm there kind of slapping people's wrists saying, no, 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 we have to have these standards in place to make sure our code is as robust as possible, and we can get it out into production, and we're comfortable that that is actually going to be as robust as possible, and we've tested it, and we're happy with it. So data engineering versus software engineering, yes, they are very similar, but they're also very different. So what is the difference? Essentially, as a software engineer, I worked as an OO programmer, so you need to know object orientation, design patterns, and then also I worked as a functional programmer, so as a functional programmer, you're expected to know about category theory. But as a data engineer, you essentially also need to know about the different design patterns, to different data processing and storage architectures, including Kappa, Delta, Lambda architectures, and essentially star schemas, being able to actually design a warehouse. So data engineers need to understand different data storage offerings and when to use them, including relational databases like SQL Server and Oracle, when to use key value, so Amazon DynamoDB, Redis, graph databases, so Neo4j, Azure Cosmos DB, and then document databases, so Elastic, MongoDB. Essentially, we need to be able to look and decide which database to use and where, and that is really key. So again, what is the difference? Data engineers need to know which compute offering to use and when, and where to host them, including. So we've looked at the data storage, but what about the compute? So Kubernetes, Docker, custom applications. You might want to write something from scratch. You might have a good use case for that. So working with things like Azure Web Apps and Node, Spark, Databricks, and event-driven serverless functions. So if you're working in AWS, you might be working with Amazon Lambdas, or you might be working with Azure Functions. And these are just a select few examples. So I'm going to hand over to Ust now to talk about his journey.
Oh, thank you. So a long, long time ago, in a galaxy far, far away, I didn't want to be Han Solo. I wanted to be Indiana Jones, because he robbed graves and fought bad guys, and that's cool, right? But when I did work experience as an archaeologist, it was boring. It was being in a field, and I hated it. So I joined the army, and spoiler alert, it's a lot of fields. And the bad guys aren't really that bad. So I didn't really know what to do once I left the army. I've been to university, and with my history degree, I decided that I would take what I learned, being some analysis of events, and became a data analyst. So this is where I kind of picked up a lot of Excel, and Excel has stayed with me throughout, as well as some other stuff. And then I became an insight manager, and this is kind of back in the day of before data science, but basically doing data science. And picked up some SQL, picked up some R, doing some very clever stuff, but perhaps not using things in the right way. So I started at the bottom, became a BI consultant, and learned how to do things properly. So I learned how to write SQL, and I learned that out of SQL bits in 2015. And then SSIS, SSAS, et cetera, and picked up a lot of the softer skills that you kind of need as a consultant, but also as an engineer. I then kind of popped my hat in the ring, decided to kind of go in-house as head of BI, and there was way too much Excel, even for me. I was doing very complex financial modeling, and it was scary. And I was thinking, like, what am I doing here? So I went to become a data engineering consultant instead. So I picked up some new skills, refreshed some old skills, but effectively I'm still using the same skills I learned a long time ago, not just Excel, but SQL. SQL has been largely the forefront across the large portion of my established career within data. So, quite frankly, I am still a data generalist, despite having the label of a data engineer. I love solving problems with data. I love the problems that data presents, which is why I love data engineering. And fundamentally, data engineering makes everything work. You can't do anything with data without engineering. Okay.
Thanks, East. Okay, so hopefully we've done everything that we set out to do today. So we've described what is a data engineer. We've gone through the tools and the technology, and hopefully give you some indication by our own stories that it is a really, really accessible field to get into, and something that you should genuinely consider. As some takeaways, we've just compiled a few things that we hope can help you. So we put together a reading list. There's an absolute ton of books out there. The QR code will basically take you to an Amazon book list that we kind of recommend that you use as a starting point. We're going to add to that once we read more things ourselves. So we'll try and keep that up to date with any developments in data engineering. There's a lot of cool websites out there. You're still going to be massively on Stack Overflow, which is a win because it's awesome. I use Catherine's website a lot for learning ADF. She's truly marvelous at it and teaches it in a really, really simplified way that anybody can pick up from. Databricks have both a community page and the Databricks Academy website, which has some great free content on there. There's the Azure community website, which has some stuff on, and Spark, by example, is really, really good for some very specific problems that you have with Spark. It gives you lots of really good code samples. Video-wise, Advancing have a very good video section by Mr. Hello Spark fans himself, Simon Whiteley, does most of the work on there. But we do have other things on there for introductions to data science and other aspects of data engineering. The Seattle Data Guy, also a very good one. Easy to watch content, easy to pick things up from. The Databricks YouTube channel is superb as well. It has a number of things directly from the Databricks Academy on there, and a lot of sessions from the various conferences that they run. And finally, we have Brian Kafaki, who's a very similar presenter to what Simon is. He just deals with kind of what's hot, gives you in-depth examples on how to learn Spark and things like that. Most importantly, use the community. The user groups are doing more and more sessions, particularly on things that are related to data engineering. There's a few more conferences coming up in the UK. Again, go to the Microsoft Azure learning pages, and Azure SQL bits. There's still a whole bunch of sessions that are related to data engineering, which we've kindly just listed to you. There's some starting straight after this, so you've got time to grab a coffee and go to one of those sessions. Then there's a couple more around 5 o'clock. A whole truckload of sessions tomorrow on it. Incidentally, these slides will be available shortly after the presentation's finished, so we'll get these out to you. So if you want to use the list, feel free to do that. Plus, SQL bits usually put all the sessions online, so if you've missed any of these sessions or any of these sessions, grab the recordings and just kind of absorb yourself in as much information as you can. If there is anything that's not covered by those, just grab us. We love talking about data and we love helping people. So the three of us have our contact details on here. Get us on Twitter. you can get us via the website as well at Advanced Analytics. Finally, that's the end. Don't forget to leave us feedback. They've got a brilliant thing at BITS this year where they're going to plant a tree for every 10 feedbacks they do, and there's competitions associated with it. I think we're time, aren't we? So thanks for coming. Hope you joined us soon. Thank you. Did we get your Q&A? No, that's okay. Yeah, if anyone's got any questions, we'll be around the air booth or the community zone later, so just come and find us. Thank you.